So in this example, it is given that why is it found experimentally difficult to detect neutrinos in a nuclear beta decay. Now, this question says that neutrinos do exist, but they are not detectable easily in a nuclear beta decay. Now we have to tell the basic reason behind why they are not easily detected. So the reason for that, before that I would like to tell you something about the beta decay. So let's discuss the beta plus decay and beta minus decay. So this is a case of a beta minus decay in which we can see that one of the neutrons is getting reduced and one of the protons is getting added, and the inverse is happening in the next case, that is the beta plus decay, in which one of the neutrons is increasing and one of the protons is decreasing. So in one case we get an antineutrino and an electron, and in the other we get a neutrino and a positron. So it is very clear that neutrino does exist, and it is just that we were incapable to detect it because we were not technologically advanced. So let me take you to a story that has been given. You can read in articles also that there were early studies of beta decay, and they revealed a continuous energy spectrum up to a maximum, unlike the predictable energy of alpha particles. Another anomaly was the fact that the nuclear recoil was not in the direction opposite to the momentum of the electron. The emission of another particle was a probable explanation to this behavior, but searches found no evidence of either mass. Now this is very important. There was no evidence of either mass or charge. Now because they said that there is a particle, but we didn't find any mass or charge because of charge conservation and mass conservation. So the interesting history has Wolfgang Pauli in 1930 proposing an as yet unobserved particle to explain the continuous distribution of energy of the emitted electrons. That he said that there is something, but we are not able to detect it. Then there was another scientist, Enrico Fermi, and he called this particle a neutrino and developed a theory of beta decay in which the neutrino carried away the missing energy and momentum. So this particle explained everything. Now, why was it difficult to detect? Because of the same reason. It had no charge and almost no mass. So it was very hard to detect. So the answer to our question would be very simple, in which we will say neutrinos are having no charge and massless. So these two things make it hard to detect. So that will be the most precise answer to this question.